A long, long time ago, in a galaxy far away, statistics was under attack. And I thought me and Qui-Gon Jinn. Wait a second, that's Star Wars. No, it's not. It's Weird Al. Yeah, it's both. Welcome to Statistics. So helping you with Activity 5-1, city temperatures, kind of guiding you through this to make sure you know what you're doing. The following table reports the average monthly temperatures for San Francisco, California. I've been there. It's pretty cold. It's pretty awesome. Never been to Raleigh, North Carolina. Is that how you say it? Raleigh? 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 Raleigh, North Carolina. Raleigh. So we have January, 39. In San Francisco is 49. So it looks like it's a little bit colder in North Carolina. And then it gets warmer. So it actually does end up getting warmer in Raleigh, and then San Francisco, a little bit cooler. And then back to December, a bit cooler. Still nothing like Utah with our freezing cold, below temperature, freezing, snowing. We love Utah. Okay, so that's a dot plot. So please calculate the median of these temperatures for each city. Remember to arrange them in order first. Well, first, let's see how many we have. Well, January to December is 12 months. Cool. So then we have 12 months. And so what that means is that we're going to have an even set of data. And so we're going to use that formula for finding an even set, n over 2. And then just one more, n over 2 plus 1. And so you got to put them in order from least to greatest. And so we'll go and do Raleigh together. And then you need to do San Francisco. Okay, so Raleigh, we have 39, 42, 50, 59, 67, 74, 78. So almost in order, but we got to kind of switch it around there. So after 42, so 39, then 42. Next is 43, then 50, then 51. Then what's after 51? 59, and then 60. Nice. So what we're doing right now is we're just putting them in order from least to greatest. So after 60 then is 67, nice. After 67 is, 67, then we have 71, then we have 74, 77, 78. So I put them all in order from least to greatest. And now we want to work our way into the middle. So we have 12 months, even number. So we just do 12 divided by 2, which is 6. Nice. So we're looking for the 6 plus 1, 7th position. So we're going to go 1, 2, 3, 4, 5, 6th and 7th position. 8th, 9th, 10th, 11th, 12th. Yep. So we're looking for those two averaged together. So Raleigh would be 59 plus 60, because we had to divide it by 2. And so that'll give us between the two, which is 59.5 degrees. Remember the range of data in order first. So you go ahead and now try to find San Francisco's median, doing the same kind of process, but go ahead and put these numbers in order first. Nice. Are they close to each other? Yes or no? You answer that question. Since the centers of these distributions are, I guess yes. One can conclude that there's no difference between the two cities. Monthly temperature explain. So which city has more variability? Okay, so this part B is saying, so is there no difference between the two? Of course there is. Yes, there's a difference. And what do you think the difference is? Well, maybe the centers are pretty close, but guess what isn't close? So yes, there is a difference. And what could we compare? We could compare their maximums and minimums, right? Yeah, so it turns out that Raleigh had a minimum of 39 and San Francisco had a minimum of 49. So there is a difference. So R for Raleigh, S for San Francisco had a minimum of 39 versus 49, right? Yeah, that's a pretty big difference, 10-degree difference. And then even if you look at San Francisco's maximum versus Raleigh's maximum, what's that we got going on in September? Wow, go to San Francisco in September. So 65 versus 78, right? Yeah, so let's put that down as well. So San Francisco had a maximum of only 65, where Raleigh had a maximum of 78. That's because the ocean front for San Francisco. So which city has more variability? So what do you think variability means in its monthly temperature? So variability is going to be just talking about which one has just a greater amount of difference between the two. And so we're about to calculate that. And that's what we're going to calculate below. And so the highest monthly temperature for Raleigh, what is the lowest? So again, for Raleigh, the highest was 78. And the lowest was 39. What's their difference? So 78 minus 39. And so let's try that. So 78 minus 39 is 39. So that's 39. Nice. So you do the same for San Francisco. I'm going to guess that 65 and 49 are not as far apart. And so as Raleigh. So we're going to go ahead and say then that Raleigh has a greater variability. And really it's because Raleigh has the greater range, right? Raleigh. So Raleigh has more variability in it because the greatest maximum minus the minimum, the greatest range has more variability. It spreads out more variability in it. Cool. Okay, so then you're going to go ahead and do part E. I helped you with C and D. And you're also going to go ahead and figure out part A. Yeah, part A. Specifically this one and this one. Probably say yes for that close one. Okay, so then we'll jump to the back side of your worksheet now. Thanks for watching this lesson and doing this with us. Statistics. Okay, you calculate it by finding the middle number between the minimum and the number just to the left of the median. Okay, just to the left of the median. So let's see here. So the example we're going to give you, so this is for Raleigh, and let me double check. Yeah, this is for Raleigh. So I'm actually going to do San Francisco. Oh, they did San Francisco for us. So let's show you how they actually did that, okay? So how they did San Francisco is they took these numbers here. They put them in order from least to greatest, right? So 49, 49. So kind of underline or circle it when you've used it, which we just did. We wrote it down. Next is 52, 53. Nice. 55, 56, 58, 52, 53, 55, 56, 58, nice. Okay, after 58, what do we have left? So 61, 62, all in order, 63, 64, 65. Nice. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so those are our 12 numbers there. And so to find the, so you got to find the median first. And so they tell us the median, so that's going to be between the 5th and 6th position. Because again, our 6th and 7th position, 12 divided by 2, or n divided by 2, is the 6th position, and one more, 7th position. That's going to be where our median positions are. Or if you want to work your way into the middle, 1, 1, 2, 2, 3, 3, working our way into the middle. Find the median. There it is. Divide by 2. Da, 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 da. So there's our median, which is 57. Nice. Hopefully that's what you got on the front too. Okay, so there's 57, which they gave us right there. Now, for San Francisco, how did they come up with 52.5 and 62.5, right? So what they're going to do, because it's a little bit trickier with an even set of numbers, is from the median, which is 57, is our MED, the median. We're going to go ahead and kind of block that off here, and then here, and here. So we're going to divide it up, and now we're going to just use those sets of data to find, so the number just to the left of the median, which is 57, and the number to the right, which is 49. And now we're going to go ahead and work our way into the middle there. So we can go 49 to 49, 56 to 55, 49 to 52, and then 55 to 53. So those are the two median numbers that we're going to add together and divide by 2, average them. So that's going to give us, draw a line down the middle, so that's going to give us 52 and 53 is what, 105, add them together, and then divide by 2, and we should get 52.5. And so that's going to be Q1 is what that's going to be. That's going to be Q1. And then if we do the same over here, wah, 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 wah. So now just in between there is going to be 62.5 averaged together, divide by 2. And so that's 62. Wow. 62.5. That's going to be Q3. That's going to be your upper median. Lower median, upper median. Cool. So that's how they came up with that 5-number summary there for this guy and this guy, as well as our minimum maximum. So now you need to find Raleigh's data using the data up there or from the backside. Use Raleigh's data to fill in those squares. And also find their RQR, which again, the IQR when you get to it is going to be Q3 minus Q1. And then, awesome. So find the interquartile range for Raleigh's data. And then, is it more or less than San Francisco's? So go ahead and find San Francisco's, and which turns out to be 10. Oh, because it's 62.5 minus 52.5, which is just 10. And so San Francisco's IQR is 10. So is Raleigh's going to be more or less? So you find out what it is using the IQR interquartile range, which again is Q3, whatever you find for Q3, minus Q1. So whatever you find for Q3, go ahead and put here. Whatever you find for Q1, so there's Q3, upper quartile, and Q1, find that one as well, that's the lower quartile. And so find both of those, and then go ahead and plug them into the formula, and then let us know what you get for the IQR for Raleigh. And then put them in the box there. Put upper quartile, lower quartile, medium, minimum, maximum, and then there's San Francisco box plot already done for you. So then you need to go ahead and just do Raleigh's box plots, and then you got it made. Woo! Thanks for watching. Thanks for busting through this worksheet with us, which was 5-1 city temperatures. Thanks for watching. Thanks for watching, doing our lesson with us this week. You got this. Thanks for watching. Keep on studying. Woo! Rolling, rolling, rolling. Keep them doggies rolling. Man, my foot is swollen. Right.